In this video, we're going to be looking at expanding and scientific notation. But before we even get to scientific notation, we have to look at expanding. And we're going to start this off by just a quick review. So let's look at this here. You guys remember way back in elementary, you looked at this is 1 unit. This stick here is made up of 10 of these units. So this is our tens. This flat here is made up of 100 of these units, or 10 sticks. So 10 of these units makes a stick. Then once we have 10 of these sticks, we have 100. Then once we have 10 of these flats, we get this cube, which is 1,000 of these little units. So with that in mind, let's go right here. Here's my first example. We have 1,235. What does that mean? So looking at this number here, we have a thousands block, right? Then we have 200s block. 1, 2. And then I'm going to have 3 tens blocks. 1, 2, 3. And then we're going to have 5 units. 1, 2, 3, 4, 5. Okay? Well, I look at this now, because once we have 10 of these, it makes one of those. Once I have 10 of these, it makes one of those. So let's look at what we have here. So then, essentially, we're saying this is equal to, so I have one of these 1,000, so that's one group of 1,000, so it's 1 times 1,000. And then we're going to have plus, we have 2 groups of, so every time we say groups of, that's times 2 groups of these 100s. And then we're going to have, we have 3 groups of these 10s. And then lastly, we're going to have 5 of these 1s. So if we simplify this even more, what I'm going to end up having is this is equal to, we might say, 1,000, because 1 times 1,000, 1,000, plus 200, plus 30, plus 5. Okay? Because basically what we're looking at here is 1 times 1,000 is 1,000, 2 times 100 is 200, 3 times 10 is 30, and then 5 times 1 is 5. So that is essentially what this is in expanded form. Now this is very important when we get into something called exponents or scientific notation. Now that we know what expanded form, we're going to move into scientific notation. And I'm going to do that in a different way here. So before we get into multiplication, first we have to look at multiples of 10 and repeated multiplication. So multiples of 10. Let's take a look at something like this. Multiples of 10. If I go 100, that is equal to 10 times 10, which is the same thing as 10 squared, right? Remember, that is the value of these flats. Okay? Then let's try 1,000. That's the same as 10 times 10 times 10, which is 10 cubed. Well, that was those cubes. Hey, 10 cubed, that's a cube. Okay? Then, well, what if I want 10, what if I said 10,000? Well, that is the same thing as 10 times 10 times 10 times 10. That's 10 multiplied by itself 4 times, which is the same as 10 to the 4. I wonder if you could figure out now, what about if I said 100,000? So there's 5 zeros there. Or 5 places. Well, that's going to give me 10 times 10 times 10 times 10 times 10. 5 times. 10 multiplied by itself 5 times is going to be the same as 10 exponent 5. So why am I doing this? Well, scientific notation is something very interesting. Let's say I have a number, 5.3, and I want to multiply that by 10. Anytime I multiply by 10, all that means is we move the decimal over 1. So let's just look at 5. 5 multiplied by 10, we know that's 50. So then 5.3 multiplied by 10 is going to be 53. All right? So what about 6.35 multiplied by 10. That's going to give me 63.5. Okay? All right, well, let's try a different one here. I know I'm getting a little bit crazy. Let's try 6.35 multiplied by 100. That is the same thing as 635. Now, we also know that 6.35 multiplied by 100, and we said 100 is the same thing as 10 squared. So 6.35 multiplied by 100 is the same thing as saying 6.35 multiplied by 10 squared. Because 10 squared is 100, and that is 635. Now this part here is what we call scientific notation. That means we only have one decimal. So let's look at that here. We're going to look at something, and we want to put in scientific notation. So that's like working reverse. So let's say I have 754, and I want to put this into scientific notation. So I looked at 635. I want the decimal only after the first number. So I want this to be 7.54. Only after the first number I want the decimal. Now, what do I have to multiply 7.54 to get 754? I have to multiply that by 100. But in scientific notation, we don't say 100 or 1,000. We put it in the short form. So we put it in this form here. In exponent form, something short, so we don't get tired writing things out. So I'm going to have to say times 10 to the 2. Let's try another one here. Let's try 7,843. Now I want that in scientific notation. Okay, so what is that equal to? Well, I want the decimal here, 7.843. Now I look at this, this is actually 7,000. So altogether, really 7,000. 1, 2, 3. 3 zeros. So that means we want 10, and when we have 3 zeros, that's to the power of 3. Because if we look back here, this number tells us how many places or how many zeros there are. So that is going to be 7.84 times 10 to the power of 3. And that is this one here in scientific notation. Now if I want to go the other way around, it's actually quite easy. Let's say I have 6.4 times 10 to the 5. So this is in scientific notation, and now I want to put in something called standard form. Well, that's how we normally write numbers. Well, I look at this. This is going to be, we have to move this over 6, and then 4, and then we have to have, we move it, this is like 1 0, and we need 5 zeros all together. So there's 1, 2, 3, 4, 5. Or in other words, this means we move the decimal place over 5 times, but we'll get to that a bit later. So that is scientific notation. Right here, scientific notation, and this is standard form. Okay, we're going to do one more example here. Let's try one like this. If I have 65843, and I want to put that into I'm going to put another 0 here, and I want to put that into scientific notation. So if I want to put this in scientific notation, I want a 6 and then a decimal. Well, how many zeros should I have here? 1, 2, 3, 4, 5. So this is going to be times 10 to the 5. Now I look at this, my decimal's there, so I just put 5, 8, 4, 3. And that is all it is for scientific notation. If I want to go the other way, let's say I have 4.26 times 10 to the 8. I want to put this in standard form. Well, I'm going to have my 4, and I'm going to write on top these little zeros. 1, 2, 3, 4, 5, 6, 7, 8. Well, I'm going to have 2, 6, and then 1, 2, 3, 4, 5, 6 more zeros. So this right here is going to be my answer, because that's what that stands for. So that's the general idea of scientific notation. But is a twist. What happens if I have a negative exponent? So what happens if I have something like this? 6.4 times 10 to the negative 3. Okay. Well, we're going to get to that in the next video.